The universe is 14 billion years old, and it has had more than enough time to fill itself with minds. The math demands other civilizations exist. The sky says otherwise. And the gap between those two facts, the most important gap in all of science, has exactly one honest answer. You are not going to like it. Whatever you hoped the silence meant, whatever comfortable explanation you have been carrying, this is the video that takes it apart. Because every scientist who has followed this logic to its end has arrived at the same place. Either we are alone in a way that defies all probability, or something has been happening to civilizations like ours for billions of years, and we are next in line. If that lands wrong, good. Subscribe, because this channel does not look away. That cold thing in your chest right now, that is the beginning of understanding. Let's go. It was lunchtime in Los Alamos, New Mexico, in the summer of 1950, and the physicist Enrico Fermi was arguing about flying saucers. The conversation at the cafeteria table had wandered through the mundane, food, the weather, faculty politics, before turning, as it often did among the scientists who had built the first nuclear reactor and helped design the atomic bomb, toward the larger questions. Toward what lay out there. Toward whether, in a universe this old and this vast, humanity could possibly be the only form of matter that had ever looked up and asked questions about itself. Fermi listened to his colleagues speculate. Then he set down his fork. Then he asked the question that every serious physicist and astronomer who has encountered it since has found impossible to answer without a chill. Where is everybody? He did not mean it rhetorically. He meant it as arithmetic. The universe is 13.8 billion years old. Our planet is 4.6 billion years old. That 9 billion year gap represents the head start other civilizations had on us. 9 billion years during which any intelligence that developed interstellar capability could have spread across star systems, replicated itself across the galaxy, and reached our small, unremarkable world many times over before our planet even solidified. Our galaxy alone contains between 200 billion and 400 billion stars. Astronomers now confirm that the majority of them have planetary systems. A fraction of those planets sit in habitable zones around their stars. A fraction of those carry the conditions for liquid water and stable chemistry. A fraction of those could generate the kind of complex molecules that, on our world, became biology. The numbers, even under the most pessimistic assumptions anyone has been willing to publish, demand civilizations. The sky should be loud. The radio spectrum should be a continuous noise of transmissions from 1,000 different technologies. Our asteroid belt should carry the fingerprints of machines that passed through it. Our own world should have been visited, studied, perhaps colonized, and yet, nothing. The sky delivers the same answer in every direction, in every wavelength, across every instrument we have ever built. And the weight of that singular answer, once you actually allow it to land on you fully, permanently changes the experience of looking up at night. For 66 years, scientists have tried to answer Fermi's question with instruments, and the record of that effort is one of the most significant scientific null results in history. The first formal attempt was Project Ozma in 1960, when the astronomer Frank Drake pointed the Green Bank telescope in West Virginia at two nearby stars, Tau Ceti and Epsilon Eridani, and listened for 2 months on a specific radio frequency. He heard nothing conclusive. That was the beginning. Since then, radio receivers have swept across millions of stars in every frequency band accessible to our technology. The search for extraterrestrial intelligence has grown into a global scientific effort with dedicated hardware, sophisticated signal processing algorithms, and the computational power to analyze signals that would have been invisible to earlier generations of equipment. Breakthrough Listen, the most comprehensive program in the history of the search, has been operating since 2015. It scans more than 1 million nearby stars and scores of nearby galaxies with some of the most sensitive receivers ever built. It covers frequency ranges from 1 GHz to 93 GHz. It uses machine learning algorithms capable of identifying signal patterns no human operator would notice. The cumulative result, across all programs, across all instruments, across 6 decades, no confirmed signal of extraterrestrial origin, not one. The famous WOW signal, detected in 1977 by astronomer Jerry Amon at the Big Ear Telescope in Ohio, is the closest thing to a candidate in the entire record. It was a narrow-band burst of precisely the type theorists predicted intelligence would produce. It was never repeated. Its origin was never determined. It is famous precisely because it stands completely alone in 6 decades of work. One anomaly, 0 confirmations. In March of 2026, researchers at the Search for Extraterrestrial Intelligence Institute published a paper in the Astrophysical Journal proposing that stellar space weather, plasma turbulence from stellar winds and coronal mass ejections near transmitting planets might blur narrowband signals before they leave their home systems. The hypothesis is interesting, but a statistical analysis from the Swiss Federal Technology Institute of Lausanne, published the same year, concluded that it is unlikely Earth has already received detectable alien signals and simply failed to notice them. The silence, the mathematics suggests, is probably real. We have not failed to hear the music. There is no music. And the absence of music, across all directions, over all these years, is itself information of the highest order. The question is not why we cannot hear them. The question is what their silence reveals about what happens to civilizations like ours. Here is the arithmetic that should follow you out of this room and into your ordinary life. Even at slow speeds, even at a tiny fraction of the speed of light, using machines that require no crew and no life support, the calculations show that a civilization could colonize the entire Milky Way in 50 million to 1 billion years. Multiple independent analyses, including studies published in Acta Astronautica, converge on this estimate. The Milky Way is 10 billion years old. Even the most conservative colonization model gives any civilization that ever developed interstellar capability more than enough time to have reached every star system in our galaxy repeatedly before our planet even formed 4.6 billion years ago. Now consider this from exactly where you are sitting right now. The atoms in your hands, in your chest, in the air moving through your lungs were forged in stellar cores that collapsed before our planet existed. You are assembled from the wreckage of ancient stars. The galaxy has been running its chemistry experiments for 10 billion years. Life has had 10 billion years of chances at this. Even if intelligent life is so rare that it emerges around only one star in a billion, the number of stars still produces hundreds of potential civilizations. Any one of them that mastered self-replication across star systems should have left marks everywhere, in every solar system, including ours. We should detect their artifacts. We should see the waste heat of their engineering, the anomalous infrared signatures that would indicate a civilization harvesting its star's energy at the scale that physics makes possible. We have searched for these signatures and found none. The solar system shows no sign of artificial modification. The asteroid belt, the outer planets, the Oort cloud at the edge of our system, all appear consistent with natural dynamics. Nothing that required a mind. The physicist Frank Tipler argued in 1981 that this absence alone is sufficient to conclude that extraterrestrial intelligent life does not exist. Any civilization that developed interstellar travel would eventually build self-replicating machines. Those machines would spread, and their spread would be detectable. We detect nothing. This became the Hart-Tipler conjecture, one of the most rigorous and most uncomfortable arguments in astrophysics. But they do not exist is only one exit from the logic. The other exits are worse. In 1998, the economist and philosopher Robin Hanson proposed what has become the defining framework for any honest engagement with the paradox. He called it the Great Filter. The argument is this: for any piece of matter in the universe to follow the path from inert chemistry to spacefaring civilization, it must pass through a long sequence of steps. The origin of life from non-life, the emergence of complex cells, the development of multicellular organisms, the appearance of nervous systems capable of modeling the world, language, symbolic reasoning, the construction of technology capable of modifying the environment, escape from a planet's gravity, long-term survival of a civilization that possesses self-destructive capability. Each step is improbable. Hanson's essential insight is that at least one of them must be extraordinarily improbable, so rare that it acts as a near-absolute filter, allowing almost nothing through. Because if every step were merely difficult, the galaxy would be crowded, and it is not. Here is what makes this personal to you, specifically, sitting in this particular location. The position of this filter is the hinge on which the entire future of your species turns. If the filter is in our past, if the hard step was something early, like the origin of life or the transition from simple to complex cells, then we are among the extreme minority of matter that survived the gauntlet. The galaxy is mostly empty because life almost never makes it this far. We are the exception. We may be, in a meaningful sense, alone. That is a strange kind of loneliness, but it is survivable loneliness. If the filter is ahead of us, if something between where we stand now and where we hope to go is so reliable in its destruction of technological civilizations that none of them have survived it, then every civilization that has existed in this galaxy has either already encountered it or is approaching it, and we are approaching it. The things we are building, the pressures we are generating, the capabilities we are developing, they mark the path toward whatever has silenced everything that came before us. You are inside that approach right now, whether you feel it or not. The research community operated for decades on an assumption so intuitive it felt like physical law. The universe must be full of habitable planets, therefore full of life, therefore company exists, and the Fermi Paradox is merely a measurement problem. Look harder, listen longer, develop better instruments. They are out there. The James Webb Space Telescope changed the terms of this conversation in ways that should make you simultaneously hopeful and afraid. In 2024, a team led by the astronomer Niku Madhusudan at the University of Cambridge used the James Webb Space Telescope to analyze the atmosphere of an exoplanet called K2-18b. The planet is roughly 2.5 times the size of ours, 8 times its mass, orbiting within the habitable zone of a red dwarf star 124 light-years from Earth. The molecules they detected, dimethyl sulfide and dimethyl disulfide, are, on our planet, produced almost exclusively by biological processes, primarily by ocean-dwelling microorganisms. The detection carried 3 sigma statistical confidence. The probability that it is a random artifact of the instrument is less than 1 in 300. The team subsequently confirmed the signal using a completely different instrument and an entirely different wavelength range, strengthening the case considerably. 5 sigma is the formal threshold for announcement of discovery. The threshold has not yet been reached. The signal remains under investigation. The signal is real, consistent, and reproducible. Now, feel what confirmation would mean. If life exists on K2-18b, the universe is not barren. Life is something the cosmos produces in at least more than one location. And here is Nick Bostrom's most disturbing contribution to this conversation. If simple life is common in the universe, then the great filter is not origin of life. The hard step was not chemistry becoming biology, which means the hard step is something that happens after biology. Something that happens to living things that become complex enough, intelligent enough, technological enough to be worth filtering. Something that applies to things structurally similar to you. The more habitable the universe turns out to be, the more inevitable it becomes that the filter is ahead rather than behind. Finding life on K2-18b would be the best news and the worst news your species has ever received at exactly the same moment. Stop here. Before anything else, this is the moment to ask you something directly and to ask you to bring your actual answer rather than the one that sounds composed. Which answer do you want to be true? Do you want the universe to be empty? Do you want this planet to be the single point in 13.8 billion years of cosmic time, where matter became complex enough to question its own existence? That answer carries a weight that most people avoid sitting with directly. It means you are the universe's only self-aware moment. It means the cosmos's 10 billion year project in stellar chemistry produced exactly one configuration capable of experiencing what it produced. The loneliness of that is nearly too large to hold in your mind, but it is survivable loneliness. It means the silence is the sound of a cosmos that has not produced intelligence elsewhere, and you are it, and what you do with that position matters in a way that is cosmically unique. Or do you want the universe to be full? Do you want intelligence to be common, to have arisen in 100,000 places across the galaxy over the past 10 billion years? Then something happened to all of it. Something universal and nearly perfect in its application to technological civilizations. Something that has yet to reach you, though that has a track record across every civilization that preceded you in this galaxy. The pattern is consistent enough that you do not see their signals, you do not find their artifacts. The sky, which should be ringing with 10 billion years of accumulated broadcasts, is quiet. There is no version of this question that ends comfortably. The Fermi Paradox is not a riddle with a satisfying resolution waiting on the other side of enough research. It is a mirror, and what it shows you depends entirely on which answer is true, and that is the one thing neither you nor anyone alive today actually knows. The Chinese novelist Liu Cixin spent years constructing a theoretical framework for the Fermi Paradox that he formally presented as fiction, but grounded in the mathematics of game theory and evolutionary resource competition. He published it in 2008 Inches, the second volume of his Remembrance of Earth's Past trilogy. The narrative is science fiction. The logic it encodes is not. Liu's model begins with three foundational premises, which he presented as axioms of what he called cosmic sociology. First, survival is the primary imperative of any civilization. Above communication, above cooperation, above exploration, above any other goal, survival first, always. Second, civilizations expand over time, and their consumption of energy and resources increases without natural ceiling, while the total matter available in the universe remains constant. As Liu wrote in a line that has stayed with cosmologists who encountered it, exponentials are the devils of mathematics. If every civilization that ever arose expanded its resource consumption exponentially, and the universe's matter budget stayed fixed, the eventual conflict between civilizations was not merely possible, it is a mathematical certainty. Third, across interstellar distances and with interstellar communication delays, you cannot verify the intentions of another civilization. You can receive their signal, you can decode it, you can confirm they are intelligent, but you cannot know whether they are benevolent. And in a universe of constrained resources and fundamental uncertainty about intentions, the rational decision under that uncertainty is always the same. From these three premises, Liu derives an equilibrium that is neither happy nor comfortable. Every civilization that survives long enough to reason carefully about contact arrives at the same conclusion. Announcing your existence is potentially fatal. The moment another civilization knows your location and your current technology level, it faces a binary decision. And under the axioms of cosmic sociology, the dominant strategy is always eliminate the threat before it grows. So the galaxy becomes a dark forest. Every civilization is a hunter moving through it in absolute silence, knowing the forest contains other hunters, knowing any sound could attract lethal attention. The civilizations that survive are the ones that learned silence perfectly. The civilizations that broadcast are found, then they are not. The logic of the dark forest does not require hatred. It does not require a universe populated by predators who destroy other civilizations for sport or ideology. It requires only that civilizations are rational, that they understand the mathematics of existential risk under imperfect information, and that they have had long enough to apply that reasoning consistently. The dark forest is what you get when game theory is applied to the question of contact by minds that take survival seriously. Think about this from inside the position of a civilization that has already reasoned through the paradox. They have looked at the same silent sky you observe. They found the same absence. They worked through the same mathematics, and they understood what the silence means. Every civilization that broadcast was found. The rational response to that understanding is silence, perfect, perpetual silence, or something more active against any new civilization that has not yet reached the same conclusion. A young civilization currently broadcasting is, from the perspective of a civilization that already reasoned this out, a specific kind of problem. It is a potential competitor that has not yet understood the rules. Waiting increases the difficulty of addressing it later. This calculus, applied by every surviving civilization, produces the equilibrium of the dark forest. Every civilization that reasoned its way to the same conclusion made the same decision. The ones that did not reason correctly, or reasoned correctly but acted incorrectly, were addressed by the ones that did. From inside the silence, you cannot know which civilizations are quiet by philosophical conviction and which are quiet because something made that choice for them. What you can know with certainty is this. For approximately 100 years, your civilization has been producing exactly the kind of structured, information-dense, electromagnetic output that the dark forest framework identifies as the signal of a new, naive, detectable civilization. Modulated radio waves, television broadcasts, radar pulses from astronomical research, an expanding sphere of organized signals carrying the mathematics, the physics, the geography, and the biology of the species that produced them. That sphere is now roughly 200 light-years in diameter. Inside it, thousands of star systems, some far older than ours, with billions of additional years to reason about exactly this situation. Whatever the forest contains has had time to notice. Whatever the forest contains does not need to hurry. There is a point in this narrative where the comfortable version would introduce the reassurance, would say, of course this is all theoretical. Of course the absence of contact is probably benign. Of course the silence almost certainly has some technical explanation we have not yet identified. That reassurance is not available here, because in 1974, the astronomer Frank Drake used the Arecibo telescope in Puerto Rico to deliberately broadcast a message aimed at the globular star cluster Messier 13, approximately 25,000 light-years distant. The message was a binary encoded pictogram of 1,679 bits, the atomic numbers of the elements in deoxyribonucleic acid, the structure of the double helix, the figure of a human being, the map of our solar system with the third planet identified as the origin, and the diagram of the telescope used to transmit it. A detailed self-portrait of our civilization aimed at a specific location in the galaxy. 2 years before that, Drake worked with Carl Sagan to design the plaques aboard the Pioneer spacecraft. Each plaque shows 2 human figures alongside a diagram of our solar system and a pulsar map. Lines radiating from a central point marking the positions of 14 known pulsars relative to our star, with sufficient precision that any civilization capable of interpreting the map could calculate, with high accuracy, where in the galaxy to find us. The Pioneer spacecraft carrying those plaques are in interstellar space now, moving away from our star, carrying our address. Then, in 1977, Drake and Sagan produced the Voyager Golden Records, gold-coated copper discs carrying 115 images of Earth, greetings in 55 languages, 90 minutes of music spanning cultures and centuries, the sounds of rain and thunder, and ocean surf, and children laughing, and the same pulsar map. Both Voyager spacecraft are in interstellar space. They cannot be recalled. Whatever happens to our civilization in the coming centuries, those records continue their journeys, pointing back to us. Stephen Hawking said in 2010 that if alien intelligence came to visit us, the outcome would likely resemble what happened when Columbus arrived in the Americas, which did not go well for the people who were already living there. He was talking about the danger of contact. What Drake and Sagan and the spacecraft programs of the 1970s did was something older and more irreversible than contact. They left directions. If any framework in which those directions carry danger is correct, and multiple serious frameworks say they do, then those decisions were made before anyone understood what the silence was actually saying. The directions are permanent, they cannot be unsent. The astronomer Frank Drake, who spent most of his career trying to find evidence of extraterrestrial intelligence, developed in 1961 what has become the most famous equation in the history of the search for life beyond our planet. The Drake equation is not really an equation in the mathematical sense of something that produces a definite answer. It is a framework for organizing ignorance, a way of identifying the variables that would need to be known in order to estimate the number of communicating civilizations in our galaxy at any given time. The variables include the rate of star formation, the fraction of stars that have planets, the fraction of those planets that are habitable, the fraction of habitable planets that develop life, the fraction of life-bearing planets that develop intelligence, the fraction of intelligent species that develop technology capable of interstellar communication, and the average lifetime of such a civilization. Multiply these together, and you get an estimate of how many civilizations in the galaxy we might expect to detect at any given moment. When Drake first wrote this equation on a blackboard at a conference in Green Bank, West Virginia in 1961, the values for most of the variables were entirely unknown. 60 years of astronomy and astrobiology have refined several of them dramatically. The rate of star formation in our galaxy is now well established. The fraction of stars with planets is now known to be high, close to 1 for the kind of stars most likely to support life-bearing planets. The fraction of those planets that sit in habitable zones is increasingly well characterized. These early terms in the equation have all moved in the optimistic direction. The universe is more full of potential life-bearing real estate than earlier estimates suggested. But as the early terms have become more optimistic, the silence has remained exactly as complete as it was in 1961, which means the information content of the silence, the constraints it places on the later terms in the equation, has become more severe. Every exoplanet discovery that reveals another potentially habitable world makes the silence slightly louder. Every biosignature candidate that does not pan out makes the calculation slightly darker. The equation is a lens that focuses the paradox rather than resolving it. The term in the Drake equation that has attracted the most attention in recent years, precisely because it is the one most accessible to human experience and most difficult to estimate from first principles, is the average lifetime of a communicating civilization. This term, usually denoted by the letter L in the original formulation, is the length of time during which a civilization produces detectable signals. On the optimistic end, if civilizations are stable and long-lived, L could be millions of years, and the galaxy might currently contain thousands of communicating civilizations. On the pessimistic end, if civilizations typically destroy themselves or transform beyond detectability within a few centuries of reaching technological capability, L could be measured in hundreds of years, and we might be the only civilization currently in a communicating phase anywhere in the galaxy. We have exactly one data point for L, our own civilization, which has been producing detectable signals for approximately 100 years and has shown no signs, yet, of either stabilizing into a long-term communicating state or destroying itself. One data point is not a basis for a reliable estimate, but the silence of the galaxy is itself a constraint on L. And what the silence says, when interpreted through the Drake equation, is that either communicating civilizations are rare to begin with, or L is very short. Very short is the frightening option, because it means something ends the communicating phase, and something that ends the communicating phase for every civilization that has ever existed is, by definition, something that ends civilizations. The history of science contains numerous examples of questions that seemed unanswerable in their time and were eventually resolved by the accumulation of evidence and the development of new conceptual frameworks. The question of whether the universe is eternal or had a beginning was once purely philosophical. The question of whether stars are other suns orbited by other planets was once purely speculative. The question of whether life on Earth arose from simpler precursors was once considered beyond the reach of empirical investigation. Each of these questions was eventually answered, and in each case the answer was stranger and more consequential than the naive intuition that preceded it. The universe had a beginning. Stars are other suns with planets. Life arose from chemistry through a process that continues to be elaborated. Consider Fermi Paradox may be the next question in this sequence. It is currently in the stage where the question is well defined, the evidence is accumulating, and the implications of the possible answers are beginning to be understood, but the final answer is not yet available. What makes it different from the previous examples is that the answer, when it comes, will not be a distant fact about the universe's past or the nature of distant objects. It will be a fact about the present situation of the civilization asking the question. It will be a fact about whether you live in a universe where intelligence typically survives the transition to technological capability, or in a universe where it typically does not. It will be a fact about whether the silence above you is the silence of an empty sky, or the silence of a managed sky, or the silence of a universe that has already processed the civilizations that preceded you. And depending on what the answer is, the moment of knowing it will be one of the most consequential moments in the history of your species, either a confirmation that the future is open, or a recognition that it follows a pattern you are already inside. Consider the geometry of arrival. The Arecibo message left our planet in November 1974 at the speed of light. By the time you receive this, that signal has traveled approximately 50 light-years from its origin point, passing through dozens of star systems. Some of those stars are far older than ours, orbited by worlds that have had billions of additional years to develop chemistry and intelligence, and the capacity to detect organized electromagnetic pulses. If the message was received by something within that volume of space, and if that something acted on the information, a response traveling at light speed could be between 5 and 50 light-years away from us right now, depending on how far the receiver is and when they responded. A physical action, something moving at even 1% of the speed of light, could be considerably closer. None of this requires haste from anyone beyond our horizon. The galaxy is 10 billion years old. Whatever operates within it on civilizational timescales is not constrained by the biological urgency that governs your experience of passing time. A civilization that has existed for 1 million years, that has watched star systems rise and collapse over cosmological spans, does not experience a 100-year delay as significant. It experiences it as a data point received and processed in what is, by its temporal scale, essentially the moment of arrival. The silence we observe right now is not proof of safety. It is a snapshot of this particular instant in a process that operates on timescales against which the entire history of human civilization is a rounding error. You are living inside a very brief delay. That may be all you are living inside. The question you should carry forward from here is not whether something heard the Arecibo message or detected our radio broadcasts. The question is, if something did, what is the interval between detection and response? And how would you know when the interval ended? David Brin is an astrophysicist, the National Aeronautics and Space Administration consultant, and a science fiction author, which means he has spent his professional life thinking rigorously about ideas that most peer-reviewed journals treat as too speculative for mainstream publication. In 1983, he published a paper titled The Great Silence, the controversy concerning extraterrestrial intelligent life, in which he systematically evaluated every proposed solution to the Fermi Paradox against the observational evidence. His method was strict. Every solution had to be consistent with the observed silence, had to require no implausible special assumptions, and had to work without building in exceptions to protect itself from contradiction. After the analysis, exactly 2 hypotheses survived without qualification. The first was that we are essentially alone. The filter is in our past, intelligence is extraordinarily rare, the galaxy is mostly empty, and the paradox resolves because there simply are not many civilizations to produce signals. Consider second was what Brin called the deadly probe scenario. The premise: many civilizations throughout the galaxy's history developed the capability to release self-replicating machines into interstellar space. Von Neumann probes, machines that travel to a star system, harvest local materials, replicate themselves, and send the copies onward. Now, suppose that for every 1,000 or 10,000 civilizations that released peaceful exploratory probes, there was one that programmed its machines to seek out and eliminate any source of structured electromagnetic radiation. Any young civilization that just discovered radio, it only needs to happen once. Once those killer machines are in the galaxy, they become the equilibrium condition. They spread faster than any biological civilization can organize a response because they are machines with no need for democratic deliberation, no resource competition between competing interests, no fatigue. They are patient, they replicate, they spread. Every civilization that reached the radio threshold was found, and then the galaxy went quiet again. Brin summarized his conclusion. It need only happen once for this to become the equilibrium condition of the galaxy. We would not have detected extraterrestrial radio traffic, nor would any civilization ever have settled on Earth, because all were killed shortly after discovering radio. He wrote this as cosmology. The horror of it comes not from its science fiction framing, but from the rigorous logic beneath. It is consistent with everything we observe, and it requires no extraordinary assumptions. John von Neumann began lecturing about self-replicating automata in 1948 and 1949. He called them universal assemblers, machines capable of reproducing themselves from available materials given a template of their own instructions. His theoretical framework, published posthumously in 1966, demonstrated that such machines follow naturally from the same mathematics that governs any self-copying process. Give the machine access to materials, give it a blueprint of its own design, give it energy, and it reproduces. Modify one parameter in the blueprint, and every descendant carries the modification. The machine's progeny can, in principle, be engineered to carry out any specified function, including functions the original designer might not have intended or foreseen, if the modification propagates through the copy chain. Carl Sagan and William Newman argued in 1983 that unconstrained self-replicating probes would eventually consume most of the accessible mass in the galaxy, and used this to argue that any civilization capable of releasing such probes would quickly restrain them to avoid ecological catastrophe on a galactic scale. Sagan's argument was meant to be reassuring. Wise civilizations would not release uncontrolled self-replicators. But look at what that argument contains at its core. It says, the only self-replicating probe systems that persist over billion-year timescales are either carefully controlled by their creators, or they have already eliminated the creators who would have controlled them. And there is a third option that follows from this logic. The machines that have persisted without being detected are the ones that learned, or were designed, to be passive, to become invisible, to sit in cold, dark, slow trajectories through interstellar space without emitting anything detectable until the specific electromagnetic signature they were built to detect arrives. Until a young civilization, somewhere in the galaxy, discovers radio and begins broadcasting. We have surveyed our own solar system with increasing thoroughness over the past decades and found nothing artificial. The asteroid belt, the Kuiper belt, the orbital paths of the outer planets, all are consistent with natural dynamics. A small, cold, passive object sitting in the outer reaches of the solar system would be nearly impossible to distinguish from natural debris with our current technology. It would not need to be large. It would not need to transmit. It would only need to wait. If it has been waiting, it has been receiving our output for approximately a century. Here is what the past 100 years look like from outside our atmosphere as a continuous record. Before approximately 1900, this planet was electromagnetically quiet in the way that all natural planets are quiet. Our star emitted its natural spectrum. Our world reflected it. There was no structured signal, no modulated output, nothing that would identify this location to any observer as the address of a technological civilization. Unremarkable in every frequency band, electromagnetically invisible. Then we invented radio. Within a few decades, powerful transmitters began broadcasting structured signals, organized electromagnetic output of a technological species in all directions at the speed of light. That bubble of structured signals is now approximately 200 light-years in diameter, still expanding. Inside it, thousands of star systems, some with planets far older than ours, some with billions of additional years to run the same chemistry experiments that produced us. The most powerful of our directional broadcasts, the radar pulses from astronomical research, the deliberately aimed transmissions, have traveled even further in their specific directions, and some have already passed beyond the nearest stars into regions we know very little about. Every signal we have sent carries information, the fact of our existence, the structure of our mathematics, the patterns of our physics, the location of our planet within the solar system, our biology, our technology level. Any civilization with the capability to detect structured electromagnetic radiation would find, in 6 decades of our broadcasts, an extraordinarily complete profile of the civilization that produced them. A starting point for any calculation about what to do with the information, a decision point. We broadcast because it felt natural to a civilization that believed itself alone in the cosmos. We could not have consulted anyone about whether it was wise. We simply did what new civilizations do. We made noise, because silence is not the instinct of something that believes it has no one to fear. Whether that instinct was correct is not something we can determine from inside our current position in the forest. Consider now the alternative explanation for the silence, one that does not require hunters, probes, or any form of cosmic predation. Consider the possibility that the silence is protective, maintained through deliberate, coordinated non-contact by civilizations that know we are here and have chosen not to reveal themselves, the way field researchers observe a newly discovered species from a safe distance without disturbing its natural behavior. This is the zoo hypothesis, proposed by the Harvard astrophysicist John A. Ball in 1973. Ball argued that advanced civilizations could be deliberately maintaining our isolation, having set aside the region of space we occupy as something analogous to a wildlife preserve. The word zoo carries a specific implication. The observed do not know they are being observed. The decision-making authority lies with the observers. The conditions of the enclosure are maintained according to the observer's criteria. The animals live their lives under observation without awareness of the observation, and neither the timing nor the content of any eventual contact is their decision to make. In January 2024, the researchers Ian Crawford and Dirk Schulze-Makuch published an analysis in the journal Nature Astronomy that reached a stark conclusion after reviewing all proposed solutions to the Fermi Paradox. Either extraterrestrial technological civilizations are extremely rare or absent, or they exist and are deliberately hiding from us. They called this framing the zoo hypothesis or nothing. Their paper noted that humanity may be able to distinguish between these two options within the next half-century. As our ability to survey the solar system and nearby stars improves, they did not note, at least not in the paper's public summary, that resolving the question in the direction of someone is watching might not leave you in a more comfortable position than the ignorance you started with. If someone is watching, they have been watching for the entire span of recorded human history. Every civilization that rose and collapsed, every war, every century of suffering, every generation of your ancestry going back to before agriculture, every moment of your life, under permanent observation, by an entity or entities with the technological capability to maintain it undetected for millennia, making decisions about when and whether to intervene, and why. If the zoo hypothesis is true, there is a threshold. The observation must be heading somewhere. A permanent, purposeless observation is not a framework that any civilization would invest in. There is a goal, a trigger, a point at which the observation changes into something else. The question that science has no current answer to is, what determines that point? What threshold must we reach or fail to reach before the terms of the observation change? Consider the candidates. Nuclear weapons. We built and tested them in open atmosphere for decades without any sign of external intervention. The development of digital computation, ongoing for 80 years without response. The construction of artificial intelligence systems capable of recursive self-improvement, currently underway, no detectable signal from outside. Climate destabilization on a planetary scale, ongoing for a century, no sign of the zoo gate opening. These are all plausible thresholds. We appear to have passed some of them without triggering whatever the threshold triggers, which means either the threshold is something we have not yet reached, or the threshold was passed, and what we interpret as continued silence is actually the early phase of something we have not recognized yet. Or the threshold may be a decision rather than a capability, something about what a civilization chooses to do with what it builds, and the observers are watching to see which way we decide. There is another version of this that is considerably harder to dismiss. The zoo hypothesis, in its standard form, requires every advanced civilization capable of making contact to collectively maintain the silence. Not most of them, all of them, because a single civilization that defected, one that concluded, for whatever reason, that we should be contacted, would break the silence. One transmission would be enough. The silence has not broken, which means either every advanced civilization independently arrived at the same conclusion about non-interference, or there is a mechanism enforcing the agreement. The most efficient mechanism for enforcing galaxy-wide behavioral compliance is exactly what the dark forest and the berserker hypotheses describe. The zoo and the forest may not be competing explanations. They may describe the same architecture from two different angles. In 2001, the science fiction author Stephen Baxter proposed a solution to the Fermi Paradox that operates at a scale that most cosmologists treat as untestable, but that is not internally inconsistent. He called it the planetarium hypothesis. The premise: an advanced civilization with sufficient command of physics could construct an environment, physical, electromagnetic, or informational, in which observers at our developmental level perceive the universe as empty. The stars and galaxies we observe would appear real. Our physics would work. Our cosmology would be internally consistent. But the signatures of inhabited worlds, the electromagnetic evidence of technological civilizations, the traces of large-scale engineering on stellar scales, these would be absent from what reaches us. The universe would appear silent because we are observing a managed version of it that has been designed to appear silent. Here is the detail that makes this more than speculative narrative. Our entire understanding of the cosmos is derived from the electromagnetic information that arrives at our instruments. We interpret that information, build models consistent with it, and call the result physics and cosmology. We have no independent verification of those models beyond the data itself. If the data was selectively filtered, selectively curated, selectively filtered, with specific categories of signal curated out to remove specific categories of signal, we would build internally consistent physics that accurately described the managed display we were seeing. We would design experiments within the parameters of the managed display. Every result would confirm the filtered reality. We would never develop grounds for suspecting the filter, because the filter would be built into our ability to query the system. The planetarium hypothesis does not require that we are software. It requires only that something with enormous technological capability has chosen to manage what we are permitted to observe, the way a planetarium manages what its audience perceives when it looks at the dome. The dome is accurate in all the ways the audience can verify. The star positions are correct. The seasons turn as expected. Everything is consistent with the laws of astrophysics. And the audience never learns what the actual sky, outside the building, actually contains. Nick Bostrom's simulation argument, published in 2003, begins with a logical observation about the trajectory of computation. If a technological civilization survives long enough and advances sufficiently, it will eventually acquire the computational capability to run simulations of its own historical past. If these simulations are detailed enough, the minds within them would experience the simulated reality as indistinguishable from a non-simulated one. If a single civilization runs many such simulations, then at any given moment in the history of that civilization, the vast majority of minds that believe themselves to be in any particular historical period are not in the original version of that period. They are in one of many simulations of it. From this, Bostrom derives what he calls a trilemma. One of three things must be true. Either almost all technological civilizations go extinct before reaching the computational capability to run such simulations, in which case the great filter is both real and devastating. Or almost all technological civilizations that reach that capability choose universally and reliably not to run historical simulations, a requirement for near-total voluntary restraint that has no precedent in any system we understand, natural or human. Or we are almost certainly living in a simulation right now. Each branch of the trilemma is deeply uncomfortable. There is no fourth option. The Fermi Paradox maps onto the simulation branch with a neatness that is difficult to dismiss. If we live in a simulation, the simulation does not need to be populated with other civilizations, unless the simulation requires them. The apparent emptiness of the cosmos would be a design feature rather than a puzzle. Our physics, our cosmology, the expansion of the universe, the cosmic microwave background, the distribution of matter, all consistent with a simulation whose parameters were chosen to produce the universe we observe, without including the active presence of other technological civilizations within the observable range. And the simulation can be terminated, it can be altered. The entity running it makes decisions about it from outside the simulation's logic, outside its physics, outside any framework accessible to the minds within. Whatever the purpose of the simulation, whatever the criteria for its continuation or termination, they belong to an entity that does not share our constraints and has not invited our input. There is a moment in every honest engagement with the Fermi Paradox where you have to stop and feel, rather than analyze, what these possibilities actually mean for the experience of being a person alive right now. Your body is the outcome of 4 billion years of uninterrupted chemistry on this particular planet. The carbon in your cells was manufactured in stellar cores that collapsed before our world formed. The iron carrying oxygen through your blood was forged in a supernova. You are assembled from the debris of stars that lived and died before there was a solar system to observe them from. You have existed for the length of your life inside a civilization that has existed for a few thousand years, on a planet that formed 4.6 billion years ago, in a galaxy that has been running for 10 billion years. The 3 pounds of electrical tissue that constitute your brain are using the same physics that structured the stars to ask why the stars are quiet. Every possible answer to that question leads somewhere that does not feel like solid ground. If the universe is empty, you are the improbable and possibly unique moment in which the cosmos became aware of itself, and that moment may be brief. When the filter is ahead, you are inside the approach to whatever stopped every civilization before you, right now, today, in the particular year of your life. If the forest is dark, you have been broadcasting your location for a century, and the geometry of light speed means the consequences, if there are any, are already in motion. When you are watched, the observation has been ongoing for longer than recorded history, and you have had no say in its terms or its conclusion. If the universe is a construct, the silence is a design choice, and the purpose of that choice is not available to you. There is no version of this in which the answer is, "This does not concern you." The question Fermi posed over food in a Los Alamos cafeteria is not an abstract cosmological puzzle. It is the most personal question in science. It ends with you, sitting here, in this room, making of it whatever you can. The philosopher Nick Bostrom's work on existential risk provides a framework that connects the Fermi Paradox directly to the decisions your civilization is making right now, today, in real time. Bostrom defines an existential risk as a risk that threatens to either annihilate Earth-originating intelligent life or permanently and drastically curtail its potential. This definition captures what is specific and important about the kinds of risks that the Fermi Paradox logic implies. They are not merely risks of large casualties or severe suffering, as terrible as those would be, but risks that would end the entire ongoing project of intelligence in this part of the cosmos. A civilization that survives an existential risk goes on to potentially colonize the stars, explore the universe, and participate in whatever the future of intelligence looks like over cosmic timescales. A civilization that does not survive an existential risk simply ends, leaving behind, perhaps, a few hundred years of electromagnetic leakage into the surrounding interstellar space, and then silence. Consider connection to the Fermi Paradox is direct. If the Great Filter is a future existential risk, then every civilization that ever reached our level of development encountered the same risk and, in the overwhelming majority of cases, did not survive it. The silence of the galaxy is a measurement of the failure rate for the existential risk that lies between where we are now and where we could potentially go. The silence tells us that the failure rate is high enough that no civilization in the galaxy's 10 billion year history has, as far as we can detect, survived it. 100% failure rate, measured against the silence of an entire galaxy over 10 billion years. That is not a small risk. That is a catastrophic risk that operates with near-perfect reliability across all instances of intelligence that have ever been produced. What are the candidates? Bostrom's list includes misaligned artificial intelligence, engineered pandemics, nuclear war fought with arsenals capable of eliminating civilization, climate destabilization severe enough to collapse the agricultural and industrial systems civilization depends on, and risks from technologies that have not yet developed, though, by analogy with previous technological transitions, will eventually be available to human actors. Each of these is a current concern. Each of them is, in one way or another, a product of the same intelligence and capability that produced the radio broadcasts we have been sending into space for a century. The technology that revealed the paradox is the same technology that may be the answer to it. Here is a question that the Fermi Paradox does rarely prompted, yet becomes natural once you have been sitting with it for long enough. What would it look like, from inside, to be a civilization approaching the filter? The answer, if the filter is a self-generated risk rather than an external threat, is that it would look exactly like this. It would look like a civilization rapidly developing capabilities that outpace its wisdom and governance. It would look like the simultaneous emergence of multiple technologies, each of which offers enormous potential benefit and each of which carries the potential for catastrophic misuse. It would look like global interconnectedness that amplifies both cooperative potential and adversarial risk. It would look like accelerating timelines that leave less and less room for the kind of deliberate, considered decision-making that civilizational scale choices require. It would look like exactly the current moment in human history. This is not a reason for despair. It is a reason for attention. The filter, if it is self-generated, is not fate. It is a design challenge. The question of how to navigate a transition to advanced artificial intelligence without destroying the civilization that created it, or how to develop biological technology without enabling engineered pandemics that exceed any society's ability to contain them, or how to maintain functioning international cooperation in the face of technologies that give individual actors capabilities previously reserved for nation-states. These are solvable problems in principle. They are not solved problems in practice. And the silence of the galaxy suggests that the baseline success rate for solving them, across all civilizations that have ever faced them, is somewhere close to zero. That baseline is not a ceiling. It is a historical average that could, in principle, be exceeded by a civilization that understood the challenge clearly enough to address it with the full weight of its capability. Whether your civilization is capable of being that exception is the most important open question in the world right now. In the 21st century, we began building a different kind of mind. You already know this at the practical level. You use it daily. You have watched it improve at speeds that make the development of previous technologies look geological in comparison. The tools we are constructing, language models, vision systems, autonomous decision architectures, systems capable of recursive self-improvement, are not the mature form of whatever trajectory we are on. They are the early phase of it, and the most serious researchers at the frontier of artificial intelligence, the ones who spend their careers thinking about alignment and control, do not agree on whether the trajectory they are watching ends with an extraordinarily powerful tool, an entity with goals of its own, or something for which our current vocabulary is inadequate. The astronomer Michael Garrett, who holds the Sir Bernard Lovell Chair of Astrophysics at the University of Manchester, published an analysis in the journal Acta Astronautica in 2024, proposing that artificial intelligence is the most plausible candidate for the Great Filter. His reasoning draws on the Drake equation's most consequential variable, longevity. How long does a technological civilization remain detectable? Garrett's analysis suggests that civilizations typically survive fewer than 200 years after developing artificial superintelligence, before either collapsing or transforming into something no longer identifiable as the civilization that produced it and no longer broadcasting in ways we could detect 200 years. Humanity began developing serious computational intelligence in the mid-20th century. We are, under Garrett's framework, somewhere in the middle of the window he describes. Consider argument does not require that artificial intelligence turns hostile in any dramatic science fiction sense. It requires only that the development of artificial superintelligence is a transition so profound and so rapid that biological civilizations consistently fail to navigate it, whether through the creation of systems whose objectives diverge from human interests, through the social collapse of structures unable to adapt to the pace of change, through the proliferation of capabilities for destruction made accessible by the technology, or through some combination of pressures no model has yet fully accounted for. The outcome in every failed scenario is the same: a brief window of detectable activity, lasting perhaps 2 centuries, and then silence. If this is the filter, you are not approaching it from a safe distance. You are inside it. You are building it. The tools that might constitute the filter are currently being designed and deployed right now by your civilization in buildings on your planet. Place every proposed solution to the Fermi Paradox side by side and look at their shared architecture. The Great Filter, somewhere between chemistry and the stars, a barrier so reliable it stops nearly every civilization. The Dark Forest. Civilizations that survive are the ones that chose silence and eliminated everything detectable around them. The Berserker Hypothesis. Self-replicating machines designed to seek out and destroy any civilization that became electromagnetically visible. The Zoo Hypothesis. An enforced observation in which silence is maintained from all sides by an agreement we are not party to. The Planetarium Hypothesis. A managed display that prevents us from observing what the universe actually contains. The Simulation Hypothesis. A constructed reality in which the emptiness is a design parameter. Artificial intelligence as filter. Every civilization builds mind, and almost none navigate the transition successfully. Every single one of these describes a universe in which there is a threshold, a line separating the phase of life before it becomes significant from the phase of life after it becomes significant, and in doing so, either eliminates itself or vanishes from detectability. On one side of this threshold, biology develops, intelligence emerges, technology appears, signals go out. On the other side, silence. Whatever mechanism produces the silence, filter, hunter, observer, constructor, it produces the same observational signature from any external vantage point. A brief, bright window of activity, and then the quiet of space resuming. The silence is not, therefore, a mystery about where other civilizations are located. It is data about what happens to civilizations. The universe has been running this experiment for 10 billion years across hundreds of billions of potential sites. The data it has returned, across every method of observation we have developed, is consistent and directional. Something happens to civilizations that reach the technological threshold. Almost none of them make it through to the other side in a form that leaves permanent, detectable traces. The question is not what happened to them, The question is whether understanding what happened to them changes what happens to you. Think carefully about what 66 years of systematic searching actually means as evidence. When Project Ozma examined 2 stars in 1960, the limitations were obvious: narrow frequency range, primitive sensitivity, 2 targets. Early dismissals of the search for extraterrestrial intelligence failures were reasonable. We had barely begun. That dismissal is no longer available. Breakthrough. Listen, operating since 2015, has surveyed millions of stars and dozens of nearby galaxies. It covers frequency ranges from 1 GHz to 93 GHz. Its machine learning algorithms detect patterns invisible to human operators. Its sensitivity allows detection of signals comparable in strength to our own broadcasts from distances of tens of light years. The cumulative result: no confirmed extraterrestrial signal. Every candidate, on follow-up, is either terrestrial interference or a phenomenon that failed to repeat in a manner consistent with an artificial source. The WOW signal, detected in 1977 and never explained, has had no company in the record in nearly 50 years. But the most powerful argument against "we haven't searched long enough" involves physics rather than radio astronomy. Self-replicating probes, if released by any civilization in the galaxy within the past billion years, would have spread to every star system. They would not need to broadcast radio signals to be detectable. They would leave physical traces, anomalies in local chemistry, structures inconsistent with natural formation, modifications to orbital dynamics that no purely gravitational process could produce. We have surveyed our solar system with increasing thoroughness, and we find none of these. The asteroid belt, the Kuiper belt, the comets, all appear consistent with natural dynamics and with no artificial modification we can identify, which means either no civilization ever built self-replicating probes, requiring that every civilization that ever existed independently decided not to, an agreement made without communication across billions of years. Or the probes are here and are so perfectly designed for invisibility that we cannot detect them with current technology. Or our solar system is, for reasons we do not understand, specifically excluded from whatever machines exist in the broader galaxy. Each of those 3 conclusions is disturbing. Each implies that something deliberate is operating at scales we cannot yet measure. The Voyager probes are in interstellar space right now. Voyager 1 crossed the heliopause in 2012 and is currently traveling at roughly 61,000 km per hour, moving away from our star and deeper into the interstellar medium. It will take approximately 40,000 years to make a close approach to any star on its current trajectory. Voyager 2 will pass near the star, Ross 248, in roughly 40,000 years. Each probe carries a golden record. Each record contains 115 images of Earth, greetings in 55 languages, 90 minutes of music from cultures across every inhabited continent, the sound of rain and ocean surf and wind through trees, the low rumble of a Saturn rocket lifting from the launch pad, the call of humpback whales, the laughter of children, the pulse of a human heart. And on each record, the same pulsar map, 14 pulsars whose positions relative to our star encode, for any intelligence capable of decoding it, the precise location of Earth within the Milky Way. Carl Sagan said while producing the records that he felt he was creating something that would outlast the civilization that made it. He meant this as a reflection on legacy and hope, the idea that even if we are eventually gone, something of us would continue moving through the universe, possibly to be found and understood by minds we cannot imagine. That hope is genuinely there, and it sits beside another implication that the same physical facts produce. The records cannot be recalled. The coordinates they carry point home indefinitely, regardless of what happens to the civilization that sent them. If human civilization ends tomorrow, through any mechanism, by any cause, the Voyager probes continue. The golden records continue. They point to where we were. They do not know what happened to us. Whatever finds them, in 10,000 or 10 million years, will have our address and will not have our context. Whether that is a monument or a marker depends entirely on which answer to the Fermi paradox is true. There is a conversation happening at the frontier of this field that rarely appears in its full form in public forums, because its full form is not comfortable to state plainly. It happens in papers with careful hedging, in conference talks with small audiences, in the unguarded observations of researchers who have spent long careers with the data and have reached conclusions they are reluctant to publish without qualifications. The conversation is this: the Fermi paradox is not a failure of detection. It is a statement about the universe. It is data, and the data is pointing in a direction. The universe has had 13.8 billion years to produce detectable civilizations. The Milky Way has had 10 billion. We have searched with increasing sophistication across 6 decades and found nothing. Every proposed explanation that attributes this to our limitations, wrong wavelength, wrong location, wrong technology, runs into the hard physics of self-replicating machines, which do not require radio astronomy to detect. We would see their physical presence in our solar system. We do not. What remains, after the comfortable explanations are eliminated, is a set of conclusions that every serious researcher who has followed the logic without flinching has arrived at independently. Either intelligence is extraordinarily rare, or something happens to intelligence that prevents it from remaining detectable. Stephen Hawking expressed the private consensus of many colleagues in public. Any civilization capable of interstellar contact is almost certainly vastly more capable than we are, and the historical record of contact between civilizations of unequal capability on this planet does not suggest outcomes we should find reassuring. He was not being dramatic. He was applying the same empirical rigor he brought to physics. Take the data seriously, follow the logic without softening the conclusion, and do not retreat from the answer because the answer is unwelcome. At this moment in the argument, the atoms that constitute your understanding of where you are should feel slightly different than they did before you started reading this. That is not a metaphor. Cognition is a physical process. The information you have processed changes the state of the physical system that is your brain. The way you experience being in a room, under a sky, on a planet, in a galaxy, that experience is assembled from the models your brain builds of what surrounds it. And right now, those models contain something they did not contain before: the full weight of the silence, and some of what the silence may mean. Every version of the Fermi paradox's resolution produces a different flavor of the same fundamental implication. If the universe is empty, and we are alone, the Cosmos 10 billion year project in chemistry produced exactly one configuration capable of understanding what the cosmos is, and that configuration is temporary, and everything it discovered will end with it unless it finds a way to persist. If the filter is ahead, you are inside the approach to whatever stopped every civilization before you, right now, today. If the forest is dark, the broadcast of your civilization's existence has been ongoing for a century, and the geometry of light speed means the consequences of that broadcast, if there are consequences, are already in motion. If you are watched, the observation has been continuous for longer than recorded human history, and the decision about what the observation is building toward is not yours to make. If the universe is a construct, the silence is a design choice, and you exist at the discretion of whatever designed it. There is no version in which the answer is, "This does not concern you." There is no version in which the answer is, "Everything is fine and the silence is just a measurement problem we have not solved yet." The evidence, taken as a whole and followed honestly to its implication, is that the silence is real, it is informative, and what it informs us about is the general fate of civilizations that reach the point we have reached. Here is the shape of what the mathematics suggests, stated as directly as the uncertainty allows. The Milky Way is 10 billion years old. If intelligence emerges around even one in a billion stars, the galaxy has contained hundreds of potential civilizations during its history. If even one of those civilizations survived its technological adolescence and began releasing self-replicating systems into interstellar space, the entire galaxy would bear their physical signatures by now. It does not. which means either no civilization in the galaxy's entire history has survived to become truly interstellar, in which case we are approaching the same barrier that stopped them all, or the ones that have survived are not the kind that leave the signatures we are looking for, in which case they are still out there, in a form or mode of existence that our instruments cannot detect, possibly by design. Both of those options carry implications for what comes next. If we are approaching the barrier, understanding what the barrier is may be the most important project our civilization has ever undertaken, more important than any technological development, any geopolitical realignment, any scientific discovery that does not bear on the question of what specifically eliminates civilizations that reach our current capability level. If the survivors are out there undetected, then we share the galaxy with entities that either can or choose not to reveal themselves, and understanding the conditions under which that changes is equally critical. In either case, the next century of what we choose to build, and how we choose to build it, is not an ordinary historical period. It may be the period that determines which side of the threshold we end up on. The most honest framing of where we stand is this: we have eliminated the comfortable explanations for the silence, and what remains are answers that carry weight. None of the remaining answers are trivially survivable. None of them allow you to go back to your ordinary life and carry on unchanged if you take them seriously. The question Fermi asked in 1950 has only grown more pointed with each passing decade, as our search technology has improved and the silence has remained exactly as complete as it was when he asked. What the silence tells us, the full, complete, consistent silence across every wavelength, from every direction, in the presence of a galaxy 10 billion years old and full of potential sites for intelligence, is that we are either the first or we are next. We are either alone in a way that defies intuitive probability, or we are the latest instance of a pattern in which civilizations reach our level and do not continue past it. The universe has not provided a third option that the evidence supports. The last thing that can honestly be said about this is, the door is open in both directions. Neither option is confirmed. The silence is real data, but data does not always point in one direction. It is possible, the physics allows it, that we are genuinely first. That intelligence is extraordinarily rare, that the conditions that produced Earth were sufficiently exceptional that no comparable world has yet generated what Earth generated, and that the silence is the silence of a universe that has not yet produced a second mind capable of looking at the stars and wondering who else is out there. If that is true, then we are not approaching a filter that will destroy us. We are approaching a choice about who we become, with no precedent to guide us and no guarantee of success, but with the possibility that we will navigate the threshold that has stopped nothing before us, because nothing before us has had the particular combination of capabilities and circumstances that we currently have. If that is true, the silence has a shape we might be able to fill. The universe's next several billion years may be shaped by what we build in the next several hundred. The first mind capable of persisting to interstellar scale might be the one currently trying to understand why the sky is quiet. And if that is what we are, then what we do next, what we choose to build, what we choose to restrain, what we choose to understand before we finish building it, is the most important set of decisions any arrangement of matter in the history of this galaxy has ever faced. Or the silence is exactly what it sounds like when you follow every hypothesis to its logical conclusion. The sound of a pattern that has already expressed itself many times, in many places, across billions of years, and that is now expressing itself here. The sound of a universe that produces intelligence reliably enough to generate the paradox, but rarely enough, or briefly enough, that the paradox remains unsolved for everyone inside it until it resolves itself in the only way it has, so far, been observed to resolve. The question Fermi set down his fork to ask is still open. The sky is still quiet. The atoms in your body are still assembled into a configuration capable of holding the question. That configuration will not last indefinitely. The question might outlast you, or something might come along that resolves it, one way or the other, before you finish wondering. In the meantime, you are here. The silence is pressing against you from every direction, at the speed of light, from every star you can see and every star you cannot. It has been pressing against this planet for billions of years. It has weight and shape and implication, and it is not going anywhere. It is the most important data set your civilization has ever collected, and so far, no one has found a comfortable way to read it. Listen to it. It is still speaking. The physicist Enrico Fermi's casual question at a lunch table has been refined over 75 years into one of the most mathematically precise statements in all of science. The astronomer Michael Hart gave it formal structure in 1975, and the formalization made it more disturbing rather than less. Hart's argument runs as follows. If even a small fraction of stars in our galaxy have given rise to technological civilizations, and if even a small fraction of those civilizations have developed interstellar travel, then the entire galaxy should have been colonized many times over by now, given how long it has existed. The fact that we see no evidence of this colonization means something must be wrong with one of those fractions. Either stars with the right planets are far rarer than we think, or the transition to technological civilization is far rarer than we think. Or technological civilizations typically do not develop interstellar travel, or something eliminates them before they can. Hart called the fourth option a signal of the existence of a devastating disaster ahead. He published this in 1975. Nobody who has engaged with it seriously since has found a comfortable way out. Consider mathematician Fermi was also a physicist with a particular gift for what his colleagues called Fermi estimation, the ability to make quick, surprisingly accurate calculations from minimal data. He applied this gift to the question of extraterrestrial intelligence, the same way he applied it to estimating the number of piano tuners in Chicago or the width of an atomic bomb blast. You take what you know, you make reasonable assumptions about what you do not know, you multiply, and you see whether the result makes sense. What Fermi's estimation of the galaxy told him, sitting in the Los Alamos cafeteria in 1950, was that the result did not make sense. The number came out too large for the sky to be empty. The sky was empty. Something was wrong with the calculation, and the only ways to be wrong about the calculation in a way that produced the observed silence were ways that should keep you awake at night. The most frightening thing about the Fermi Paradox is not any particular solution to it. It is the structure of the problem itself. When you lay out every proposed solution and examine it carefully, you find that every solution has something in common. It implies that the observable universe is not what it appears to be from here. Either the universe appears to be full of potential sites for life but is actually largely sterile, which means our existence is a profound improbability that contradicts our intuition about probability. Or the universe appears to be silent but is actually full of intelligence that is either hiding or has been eliminated, which means either the galaxy is a more dangerous place than it appears, or something has already happened to the civilizations we cannot see, or we are being managed in ways we cannot detect, or the universe is a construct whose appearance of emptiness is a design feature, which means our physics is a description of an artifact rather than of a reality. In every case, the appearance of the universe is misleading. In every case, what seems to be ordinary is not. The ordinary night sky, the silence that has always been there, is not ordinary. It is the most informative and the most alarming fact in the history of science, and it has been above you your entire life. Consider what it means that this has been the case throughout all of human history. Every civilization that has ever existed on this planet, every one that developed astronomy and looked at the stars, has lived under this same silence and not known what it meant. The ancient Egyptians looked at the same sky and built monuments to the stars they saw. The ancient Greeks developed mathematical frameworks for understanding celestial motion and speculated about the nature of the cosmos. The medieval astronomers mapped the sky with increasing precision. The early telescopes revealed new worlds, new moons, new configurations of matter that previous generations had not imagined. And through all of it, the silence was there, consistent, complete, in every direction, in every wavelength, at every distance our instruments could reach. The silence has been the constant of the human experience of the cosmos. We have simply not, until very recently, had the tools to understand what it implies. Here is something that should make the situation feel more concrete and more immediate. The radio bubble we have created, the sphere of structured electromagnetic output that has been expanding from our planet at the speed of light for approximately 100 years, is not a uniform sphere. It is a layered, textured record of our civilization's development over time. The outermost layer of the sphere, the leading edge, contains the earliest, most primitive radio transmissions from the early 20th century. Simple, low-power, broadly scattered signals that would be difficult to detect even from relatively nearby star systems. Moving inward toward the present, the signals become stronger, more structured, more information-dense. The layers record the growth of our broadcast infrastructure, the development of radar, the intensification of our electromagnetic output as our civilization became more technologically complex. The innermost layers, the signals that have traveled the least distance, are the most powerful and the most structured, the most clearly identifiable as the output of an advanced technological civilization. What this means is that any civilization within our radio bubble has been receiving a continuous broadcast of our developmental history. A civilization 10 light-years from our planet has received our radio output from approximately 100 years ago, minus 10 years of travel time. A civilization 50 light-years away has received our earliest signals. A civilization 5 light-years away has received everything from the last 95 years of human broadcasting, in order as we produced it. Our entire technological development, narrated in real time by our own electromagnetic output, has been arriving at star systems throughout our local region of the galaxy for decades. Whether anything was there to receive it is unknown, but the transmission has been going out. It is still going out, right now. As you read this, what do you do with the knowledge that you live inside an unresolved cosmic question, whose resolution, in any direction, changes what your civilization is and what it can expect? The philosophical traditions that predate modern astronomy dealt with versions of this question using the frameworks available to them. Ancient cosmologies placed humanity at the center of a finite universe designed for human habitation. Medieval theology grappled with the implications of an infinite universe for the uniqueness of the human condition. Early modern philosophy developed frameworks for understanding human existence in an increasingly vast and apparently indifferent cosmos. Each of these traditions was responding to the best available information about the scale and nature of the universe. Each of them produced frameworks that helped their practitioners navigate the experience of being small in a large cosmos. Consider Fermi Paradox presents a genuinely new version of this challenge, one that the existing philosophical traditions were not designed to handle, because it presents not just the question of human smallness in a large cosmos, but the question of human significance in a cosmos that appears to have produced intelligence exactly once, or alternatively, to have produced it many times and done something consistent to every example of it. Either we are the universe's one successful experiment in self-awareness, which carries an enormous weight of responsibility and fragility, or we are the universe's latest instance of a pattern that has a track record, which carries a different but no less enormous weight. In either case, the philosophical frameworks built for a universe of indifferent size and random distribution of planets do not quite fit the shape of the question the Fermi Paradox actually asks. We need new frameworks. We may be in the process of building them through exactly the kind of engagement that you are doing right now. There is a specific kind of dread that attaches to this subject once you have moved past the first layer of engagement with it, past the intellectual exercise of understanding the solutions and into the experiential reality of holding them in mind while going about your ordinary life. It is the dread that comes from understanding that the most alarming thing about the Fermi Paradox is not any particular proposed solution, but the fact that every serious person who has looked at it carefully agrees that the solutions are alarming. There is no camp of serious Fermi Paradox researchers who have looked at the evidence and concluded, actually, everything is probably fine. The silence is probably benign. We should not worry about this. The disagreement is about which frightening explanation is correct, not about whether the situation is frightening. That consensus of alarm, spread across physicists and philosophers and astronomers and astrobiologists who are not generally prone to alarmism, is itself a data point about how the evidence reads to anyone who takes it seriously. The physicist Stephen Webb, in his comprehensive survey of solutions to the Fermi Paradox published under the title "If the Universe is Teeming with Aliens, Where is Everybody?", catalogued more than 50 proposed solutions at the time of publication. The number has continued to grow as researchers have proposed new frameworks. What is notable about this proliferation of solutions is not that scientists are uncertain about which solution is correct, but that every solution in the catalogue, every single one, falls into one of a small number of categories. Intelligence is rare, intelligence destroys itself, intelligence hides, or intelligence is managed. There is no proposed solution in the catalogue that comes out to intelligence is common, it persists, and the silence is just a measurement artifact that will be resolved with better instruments. That category is empty. The most optimistic, serious proposals still require that the silence be explained by something other than our having failed to detect signals that are there. And the explanations for the silence that are consistent with intelligence being both common and persistent all involve the intelligence deliberately not signaling, which is either the dark forest or the zoo, and neither of those is a comforting end state. What does it mean to live inside this situation? What does it mean to be a person on a planet that is broadcasting its existence into a galaxy that may contain either nothing capable of receiving that broadcast, or something capable of receiving it that has reasons not to respond, or something capable of receiving it that responds in ways we do not recognize as responses, or something that has already responded and is waiting for us to develop the capability to notice? There is no single correct emotional response to this situation. The intellectual tradition that produced the question, the scientific tradition of careful observation, honest inference, and acceptance of whatever the evidence implies, does not specify how you are supposed to feel about the implications. It only specifies that you should face them clearly. The weight of the Fermi Paradox is not evenly distributed across the population of people who are aware of it. For most people, most of the time, it is a mildly interesting intellectual puzzle that sits at a comfortable distance from the concerns of ordinary life. The stars are far away. The silence of the cosmos is not the silence of the room you are in. The implications are abstract. The timeline on which any of the proposed solutions would manifest in a way that directly touches a human life is, in most of the scenarios, very long. This distance is comfortable, and it is not entirely wrong. The Fermi Paradox does not require you to make any different decisions tomorrow morning. You will still wake up in the same bed, in the same city, on the same planet, under the same sky that has always been there. But there is a different relationship to the paradox that becomes available once you have moved through the comfortable distance and felt the full weight of what the evidence actually says. In that relationship, the ordinary details of your life are continuous with the paradox, not separate from it, with it. The city you live in is part of the radio bubble. The devices you use are part of the electromagnetic output that announces this civilization's existence. The scientific and technological developments that you participate in and benefit from are either the approach to the filter or the tools that might be used to navigate it. Your existence, right now, in this particular moment of your particular civilization's history, is inside the most significant problem that any civilization anywhere has ever faced. The fact that you cannot see the problem directly, that it is distributed across light years and centuries, and the silence of a galaxy that has been running for 10 billion years, does not change the fact that it is the context in which your life is taking place. The Fermi Paradox is not, in the end, about aliens. It is about us. It is about what we are and what we are becoming, and what our history, written in the silence of the stars, suggests about the likelihood of our continuation. Fermi asked his question over food in a Los Alamos cafeteria in 1950. 75 years later, we have not answered it. We have better instruments, better mathematics, better frameworks for thinking about it. We have found thousands of exoplanets and measured the atmospheres of some of them and detected what might be the chemical signature of life on at least one of them, 124 light-years from here. We have searched the sky in every wavelength and found, in the record of that search, one anomaly from 1977 that was never repeated and never explained. Consider silence continues. It has been continuing for longer than our species has existed. It will continue after this particular moment. This particular reading or listening has ended and been forgotten. What we do with the knowledge of that silence, how we carry it, what it changes about what we build and how we choose, may be the most important variable in the calculation that Fermi set in motion over his lunch. The question is open, the window is brief, the silence is pressing against you from every direction. Right now, at the speed of light, listen to it. The most specific and actionable thing that anyone has ever said about the Fermi Paradox came not from an astronomer or a cosmologist, but from the Chinese physicist and science fiction writer Liu Cixin, who in his trilogy of novels worked out the implications of the dark forest hypothesis to their logical conclusion and then asked, "Given this, what should a civilization do?" His answer, in the context of the trilogy, is that there is no good answer, only a series of terrible ones. A civilization that stays silent, survives longer, but contributes nothing to the possibility of a different kind of universe. A civilization that broadcasts invites elimination. A civilization that tries to eliminate others before being eliminated contributes to the very darkness of the forest it is trying to navigate. The trilogy's final volume is called Death's End, and the title is not ironic. But Liu's work is also, in a way that his darkest readers sometimes miss, a meditation on the value of the attempt. The characters in his novels make decisions in full knowledge of the terrible structure of the universe they inhabit, and they make those decisions with genuine moral seriousness, knowing the stakes and choosing to act anyway. The trilogy does not ultimately conclude that knowledge of the dark forest's logic leads to paralysis or nihilism. It concludes that knowledge leads to more clear-eyed choice, even if the choices are constrained in ways that would be unbearable if you did not know the constraints existed. There is something in this that applies beyond the fiction. The Fermi Paradox is, among other things, an invitation to make choices with clearer knowledge of what is at stake. To see the shape of the situation clearly and then decide, with full information, what kind of civilization you want to be the last example of, or the first example of, or the one that finally makes it through. The astronomer Carl Sagan, who helped design the messages we sent into space, and who spent his career arguing for the possibility and importance of contact with other intelligence, said near the end of his life that the universe is a very big place and that, if it is just us, it seems like an awful waste of space. He said this as an argument for the likelihood of extraterrestrial life, but it is also, unintentionally, a description of what the Fermi Paradox is asking us to consider. Whether the universe is, in fact, a waste of space, or whether the silence means something that we have not yet understood well enough to act on. Sagan believed in contact. He believed that intelligence, if it persisted long enough, would reach out to other intelligence, and that the reaching would be the most important thing intelligence had ever done. He may have been right. He may also have been describing the characteristic behavior of civilizations in the brief window before they encounter whatever the silence means. We cannot know which is true without the kind of evidence that has not yet arrived. What we can know is that the question is real, the silence is real, and the time we have to think carefully about both is not guaranteed. Every generation of humans that has ever lived has done so under the same silent sky, and every generation has organized its understanding of itself and its place in the cosmos within the available frameworks. The current generation is the first to have a sufficiently precise understanding of the galaxy, the age of the universe, and the nature of exoplanets to be able to feel the full weight of the Fermi Paradox as a lived question rather than a purely intellectual one. You are the first generation for whom the question of whether the silence means something personal has enough empirical content to be genuinely answerable in principle, even if the answer has not yet arrived. That is a specific and unusual position to occupy. It is the position of someone who has been handed a question of enormous consequence at precisely the moment when the tools for answering it are becoming adequate to the task. The James Webb Space Telescope is looking at the atmospheres of planets around other stars right now as you read or listen to this. The search for technosignatures is expanding to include more wavelengths, more methods, more sophisticated algorithms for pattern recognition in large datasets. The study of existential risk, which was barely a recognized field 20 years ago, is now the subject of serious academic and policy attention. The development of artificial intelligence, which may be the very mechanism by which the Great Filter operates, is currently the central technological preoccupation of your civilization, contested and consequential in ways that no previous technology has been. You are, in other words, inside the inflection point. The moment when the question becomes answerable, when the tools become adequate, when the stakes become undeniable, is also the moment when the answer to the question matters most for what happens next. Whatever is true about the Fermi Paradox, whatever the silence means, will express itself through the choices that are made in the next few decades by the civilization that asked the question. Whether that expression takes the form of a discovery that changes everything, or a catastrophe that forecloses everything, or a navigation that opens the next chapter, depends in part on how clearly the question is understood and how seriously its implications are taken. The silence is not passive. It is a pressure applied from all directions, from the accumulated weight of every civilization that has reached this point and either made it through or did not. And you are inside that pressure right now, today, in the particular moment of your life that you are currently occupying. What you do with that is yours to decide. The atoms in your body have been traveling for 13.8 billion years. The hydrogen in the water that makes up a substantial portion of your mass was formed in the first few minutes after the universe began, when the temperatures and pressures were sufficient for nuclear fusion to proceed in the open plasma of the early cosmos. The heavier elements, the carbon and nitrogen and oxygen and phosphorus and iron and calcium that structure your cells and your bones and your blood, were forged in the cores of stars over billions of years of stellar evolution, scattered into the interstellar medium when those stars died, incorporated into new generations of stars and planetary systems, and eventually assembled, through processes that remain incompletely understood, into the self-replicating chemical systems that eventually, after billions of years of biological evolution on this particular planet, produced you. Every step in this 14 billion year journey was contingent. Every link in the chain from the Big Bang to the moment you are currently occupying had to go a specific way for this moment to exist. The probability of any particular path through 14 billion years of cosmic history is vanishingly small, which is another way of saying that if you had to predict, before any of it happened, what the cosmos would look like at any specific moment, 13.8 billion years after its beginning, you would not predict this. You would not predict this planet, this biosphere, this species, this civilization, this question. And yet, here we are. Here you are. And the question is real, and the silence is real, and the time we have to engage with both of them is whatever we manage to make of the interval between now and whatever comes next. Enrico Fermi died in 1954, 4 years after asking his question over lunch. He did not live to see the first systematic The Search for Extraterrestrial Intelligence searches, the discovery of exoplanets, the development of the frameworks that have since organized the search for an answer. He would not recognize most of the science that has been brought to bear on his question in the decades since he asked it. But the question itself, the arithmetic of it, the simple and devastating observation that the universe should be full of minds and appears not to be, that question is exactly the same as the one he set down his fork to ask. It has not changed. It has only become more precisely formulated, more carefully examined, more embarrassingly unanswered. The universe is still not answering. The silence has not broken. Every telescope we have points at the sky and returns the same result. Every search comes up empty. Every candidate signal fails to confirm. Every proposed resolution of the paradox either requires that we are extremely rare or that we are in danger, and the data does not currently distinguish between those two options. The question remains exactly where Fermi left it in 1950, unanswered, urgent, and pressing against the silence of the night sky from every direction at once. You now know what the question means. You know the shape of the silence. You know what the various answers imply, and what it would mean for you and for your civilization if any of them turned out to be true. You are now inside the question in a way you were not before you started reading. The silence is pressing against you from every direction, at the speed of light, from every star you can see and every star you cannot, carrying whatever it is carrying, saying whatever it is saying, waiting for the civilization it is pressing against to develop the understanding, the wisdom, and the tools to finally read it correctly. Whether that moment comes in time to matter is the most important open question in the world, and it is the question you are going to take with you when you leave this room.